All right. Why don't we just go ahead and get started, and then more people should trickle in a little bit. Sound good? All right.
Good.
Cool. All right. Hi, and welcome everyone, and thank you for joining us today. I'm Alex. I'm your moderator today, and we're excited to bring you the latest on our ultra-temperature powder bed fusion technology, presented today by our European colleague, Markus Kluth. Markus is our technical sales manager, bringing over 20 years of experience in the plastic extrusion industry, along with 3 years in additive manufacturing. Today's webinar is especially significant as we'll be sharing insights from a recent beta test of our super and ultra temperature powder bed fusion system in partnership with AM-Rauch. We're thrilled to welcome 2 expert guests from AM-Rauch to share their experience with us. First, we have Mr. Bernard Rauch, managing partner at AM-Rauch, who brings 12 years of experience in laser powder bed fusion with high-performance polymer, specialized in process and application development, as well as application qualification. Joining him is Dr. Andreas Pfister, a polymer chemist responsible for R&D and quality at AM-Rauch. With 17 years of polymer material R&D for the additive manufacturing industry. We have dedicated time for Q&A today at the end of the presentation. So please feel free to drop your questions in the Q&A, and we'll make sure to address them at the end. And lastly, this session is being recorded for future consumption. Now, without any further ado, let's dive in. Mr. Kluth, Mr. Markus, you have the floor.
Thanks, Alex, for the introduction. I will take it from here. So let's take a look first at the agenda of today. I will present a little bit about the Farsoon itself. Then I will dive a little bit deeper in our portfolio. Then we will have a look about our so-called new system, UT252P, and their advanced thermal control, and then we will have a look about our material versatility and application potential. So here, Farsoon has been for many years known for its expansive range of AM systems and our open for industry approach. Our open platforms enables users to flexibility adjust materials and process parameters. Not only adjust materials and process parameters, we also open for system customizations in case the customer has any needs on that. And of course, we cooperate with major software brands when it comes to software infrastructure. The Farsoon Europe team, count by 20 employees for the moment, is composed of industry professionals with extensive knowledge in engineering, material science, and additive manufacturing technology. We are passionate about providing innovative solutions and service support faced by our clients in this dynamic market. And as you can see here, service engineers are based in the specific countries where our customers are across all Europe. Also, we are working with exclusive sales agents throughout Europe to enhance our market presence to provide tailored solutions for our customers. Here's a quick look at it. For Poland, we work with a sales agent. For Austria, with Mostec, for example, Italy, Intec. Portugal, Spain, we have Maxcenter on the line, and France, 3D Solutions. Here you may see a small selection of our reference customers. They more or less placed here from the left to the right. So on the left side, we have more academica ones. In the center, the majority for the moment, we have part producers like AM-Rauch. And at the end, we have end applications, for example, OEMs like BMW, Brose, Continental, and so on. So now we will dive a little bit deeper on our polymer solutions. Here, you may see our current portfolio. polymer portfolio. In addition to these, we offer even a larger portfolio of solutions for metal powder bed fusion, but today we would like to focus on our polymer solutions. As you may see here, we offer 3 platform sizes with various configurations, including fiber laser technology, so-called flight, and CO2 lasers. Our current portfolio supports powder bed temperatures ranging from 190 degrees to 280 degrees, which you see at the very bottom. So if you look at the graph here, in addition to our portfolio, we now offer the new UT252P, which you may see in the very top. Here we have a build temperature of about 340 degrees, which is a very good addition into our current portfolio. So let's have a look more detailed, what is the UT252P about? So with our new system, we achieve a stable sintering process at 340 degrees. And this is thanks to advanced temperature shielding and enhanced thermal insulation. Furthermore, it's equipped with the Farsoon heating system combined with the intelligent thermal controller and a roller coater, which is very unique in the industry, ensures a uniform part and consistent property. In line with our open policy, the UT252P is also an open platform, allowing access to process parameters and flexibility to choose a wide range of materials. Now I would like to give you an even deeper insights on the technical data of our UT252P. We highlight here the unique layer thickness adjustable from 0.06 to 0.3 millimeters. And it's equipped with a scanner which has a scanning speed of 10 meters per second. All right, so the in-house thermal control ensures a stable and uniform ultra-high temperature sintering process. And we have tested this. We observed a deviation of plus minus 3 degrees. The UT252P system is the first SLS system of its kind, featuring an ultra temperature roller recoater that's operating reliability at 340 degrees. So how we can achieve these kind of consistent part properties? The build cylinder is precision CNC machined from a solid block, greatly enhancing sealing and accuracy in high temperature environments, exceeding up to 300 degrees. The design ensures a stable and reliable printing process. So now we have heard a lot about the machines. So now we jump on the materials we have so far tested. So the UT252P was specially designed for high performance materials. It offers a broad sintering temperature range, smooth surface finishing, and high mechanical strength, making it ideal for applications in aerospace, automotive, rail and trail, of course, and for other demanding industries. Here you may see a video printing at 320 degrees Celsius. Just play the video. You can see here it's sintering well. So mentioned PEEK, it's a material which is suitable for metal applications. Here we can see a range of custom implants, for example, which later on will be placed in the body. So after the printing, of course, you also have to break out the parts. Here we will show you now a video. How does it look, the breakout, and how easy it is. You can see there's no agglomerates. That's pretty easy. Perfect. So my next slide is basically the same. That's not one it. So let's go like that. Furthermore, we have tested HT23, which is basically in PEK filled with 23% carbon fiber. Here I also can show you in video. This material was successfully validated on our UT252P. Great, so we have another layer. Nice. HT23 is certified according to FAR 25853, which is an aerospace so-called Boeing certification, and as well according to EN 45545, which is a railway certificate for flame retardant. Furthermore, I would like to emphasize that we can print these kind of lattice structures with HT23 down to 0.6 millimeters. So I'm almost at the end. Furthermore, I am pleased to announce our innovation center located in the heart of Stuttgart. It spans around 1,000 square meters, and it's dedicated to support our customers' specific needs. Here we develop customer solutions and conducting testing for various industrial applications. Of course, we also would like to host customers to have a look on our solutions. To mention, it's opening soon. You will be for sure be informed about that. All right, thank you for your attention and the interest in the capabilities of our high temperature SLS printing technology. If you'd like to have further information, feel free to reach out to me. Of course, you also can visit us at the Formnext. We will be at Hall 11.0. The booth number is E11. Here you may find my contact details for further reach out in case it's necessary. Once again, thank you very much. And now I will hand over to our partners at AM-Rauch.
Good morning or good afternoon or wherever you are located. So hello, everybody. So I would like to dive a little bit into a little bit more into powder bed fusion with high performance material, which we do since several years now, also on open machines like the Farsoon machines. So the first part of our webinar today will be an introduction of the materials we perform and the machines we use. And the second part will be done by Dr. Andreas Pfister, who is responsible for R&D and for our new department, Improve. Yeah, we are a quite old company. And in the 2000 years, we started machining mainly thermosets, but also thermoplastic materials. We have several customers in that division in medical applications. And in 2012, we started 3D printing, looking into 3D printing first with the FFF, and but very soon, already in 2013, with powder bed fusion. So that was the go for the first high temperature machine at our site for the P800 from EOS for peak HP3. And nowadays we have 4 high temperature machines for P8 series from EOS and 2 Farsoon open platforms. In the foreground, you see the UT252P, a very nice machine, especially for smaller sizes, for small quantities, and very easy to clean. So very, you can work on this machine with all kinds of materials. We even process TPEs and PA11 materials on that machine. but also PPS, which needs a temperature of 280 degrees. And behind that machine, between the P8 and the ST, you see a pilot or a beta testing machine, which we took over last year from Farsoon. It's a Flight UT501, so it has a 500 millimeter platform with a fiber laser technology. Temperatures go over 300 degrees. On this machine, actually, we process mainly PBS materials, because we have several in our program, but it would also be possible to process PKK if we wouldn't have the P8 series. Here you see some parts, samples. On the left, the dark parts, these are made of the HT23, which is an ALM material from the United States. It's a melt compound of PKK with carbon fibers, 23%. So with this material, you have even very high performance in Z direction. On the right-hand side, you see a natural PKK. Yeah, this is mainly more for electrical properties, because it's it has a very high electrical insulation properties. But despite the PEEK and PEC materials, we also process a lot of PBS materials. Here you see examples for natural PPS. So this PPS actually goes very often in manifolds and other applications in fuel cell technology, but also for electrical purposes. It's very often asked for because of its high electrical insulation. We can, and because of the Farsoon machines, we can process this material with quite thin walls due to the different setup of the machines. This is possible, so we can go down with these materials down to 0.6 millimeters. Therefore, it's also possible to process the HT23 with such thin walls on the Farsoon machine on the new UT252P. So here you see a tank cover made out of Luvocint PPS. It's a black PPS compound with very high flammability. For this material, we have a certification for rail applications, but it would also be possible to to have a certification for space and aeroplane applications. On the ST252, I already mentioned that we can process on that nice machine materials like polyketone or PA11 with carbon fibers, or PA11 with ESD properties. So it's really a universal machine on which you can do a lot of things. And so going down is always possible. You only have to take care that you don't heat too much. But the same will be possible on the UT machine. So yeah, it can go up to 340, but you can also work with 240. So that's no problem with these machines. And since we started in 2017-18 with process development, we nowadays have really a great knowledge in that kind of things. And for this, we did some funded R&D project as well. For example, with this beta testing machine, we started a project to know more about the influence of the carbon fiber for the fiber laser, which is needed for the flight technology. And from that point, we think since many years that we should also open this knowledge we have to other customers. And when I learned that Dr. Andreas Pfister is looking for a new challenge, we sat together and we developed our new division, which he will now introduce to you, Improve.
Hey, thank you, Bernd, for this introduction. Thanks. I will focus today on the new Proof division from AM-Rauch and also tell you something about the audit of the UT252P when we've been, Bernd and me, in Changsha in February, in August. We'll show you our impressions, what we had. Improve is focusing on process and application development and qualification of high-performance polymer materials for open laser sinter powder bed fusion machines like the Farsoon machines. There's a demand in the market because not everybody has the know-how to do the process development. Therefore, we offer the service. And why we offer this service for high-performance polymer? Because that's our know-how for sure. But there is a huge demand for validated and qualified high-performance polymer materials like PEEK, like PPS, within the next 3 to 10 years. In 2023, I was decided to leave the market. So no, P800 was discontinued already several years ago. P810, no new lot produced. So there's a demand for new powder bed fusion machines for high-performance polymer. And in September 2023, Farsoon announced the beta series testing in Asia for the UT252P. And we sat together with Johnny Su, with Oliver Lee, and said, hey, come on, we need to bring that from a beta to a serious machine status, so that the market has a machine, the market needs a machine. And I will tell you later more about this. So why Improve? Or what is know-how from Improve? We have together 12 years experience in high-performance polymers. Bernd, me, 17 years. From process development, material development, and business development for high-performance polymer. So we have really a global overview on high-performance polymer business and applications. We have close connections to key customers, to material suppliers, and the machine manufacturers like Farsoon, and have strong partners and cooperations also with Farsoon to develop machines and also new materials. So Farsoon and AM-Rauch decided to cooperate end of 2023 to bring the machine, the UT252P, from beta to serial status. Yeah, and so we've been both 2 times, Bernd and me, in Changsha in February, the 1st, and August. Last time you see a picture with the team from Farsoon, the very experts, polymer director Johnny Su and Chen Li, head of R&D of material and production, and Russell, the process engineer. He has the know-how to process PEEK on the UT252P. Yeah, and what were the results of our visits? In the end, we inspected the machine and checked the hardware, checked the delta to the ST252P. That was positive. The software works very well. For us, very important. In the end, hardware and software, yes, is the basis, but you need to be able to process the materials, the high-performance polymers, and there were builds run with ALM HT23 and with PEEK up to 340 degrees. And I can tell you the machine runs very well, very stable. The result is we have not from just one build. No, Farsoon did many builds from small to full builds on the machine. And the part quality is really great, I must say. But when you want to produce in serial production, you need all the quality assurance procedure. We defined that with a QA build, which will be run before the shipping of the machine at Farsoon and after installation at the customer, to be sure that you get the quality you need. We did inspection of the QA builds, and what I can say for sure, it's an open platform. You could use the material what you like, and the QA procedure is depending on the customer demand and can be adapted to the customer depending on the material the customer is tended to use. Oops, needed to check the check marks. Yeah, everything checked, everything's really great, working fine. And last but not least, you need documentation for the machine. Yeah, the user manual, for example, spare part list is available. So everything is working for Europe and also in the US. Customers in both continents can use the machine. So what can I say as a conclusion? Yeah, the Cirrus machine is a result of a really extensive development and testing at Farsoon, starting with the Alpha, 5 different beta machines to the serial machine. So that shows, and the result is really that the UT252P shows really a stable processing of high-performance polymers at temperatures up to 340 degrees. The parts have an homogeneous part quality within a build due to very good temperature distribution of the machine, but also from build to build. And what is very impressive and very unique compared to the state of the art is that you can print really very fine and stable grid structures and balls down to 0.6 millimeters with proven already with HD23 and PEEK, but I'm quite sure also with other materials, this will be possible to do so. Yeah? And this opens many new applications, as Markus already showed, also especially medical lattice structures, grid structures. That is really a very, very good market, especially for the PEEK, which is biocompatible. Yeah, so UT252 is ready to deliver. We are happy with this machine, with the result of the machine. So, but you do not need only a machine, but sometimes it's also the hurdle is, yeah, you need other market entry barriers like, where did the process from? Yeah, who is validating, who's qualifying the process? That is always sometimes an issue with open platform. If the material is not delivered by the machine manufacturer like Farsoon, because they have their own machines and materials, and they deliver a validated process for their materials. But if you have a third-party material manufacturer, very often only feasibility study with a basic parameter, process parameter is available, and the customer needs to do validation and qualification of the process if the material supplier doesn't do so. And this is a quite high effort and also high cost. And yeah, and that is what Improve can offer due to its know-how. And also other things like, customer says, okay, process responsibility, whom do I call when the process doesn't work anymore? Material supplier, Farsoon, who? In the end, yeah, that's often an open question. And you need this connecting link between machine, between material and application process that needs to be filled. And it's not overnight that you learn. It's not a very quick within a week or so to do process development. You need some time. Bernd did that on his own, did it several years, but yeah, we are there to help you. And so how does it look like? Typically, as I already said, you have the powder bed fusion machine manufacturer. He like Farsoon, who sells the machine and the service to the customer, which are OEMs or AM service providers, for example. The material supplier, he sells the non-qualified material to the customer, or the customer needs to validate and qualify material process and application, has the process responsibility. And NICE would be a connecting link who's doing process support and does the validation and qualification of the material and process, so that the customer gets rid of that process responsibility. Yeah, who's doing that? Yes, in Proof, we are offering that process development, validation, qualification. How are we doing that? The material supplier orders and supplies us with the material. The machine manufacturer, like Farsoon, provides the machine to improve. So we are doing the process development in several steps. I will come to that in the next and last slide. Material supplier gets a validated qualified material, which he can sell directly to the customer. And if the material is validated, we can offer also process support to the customer. And optionally, if there is a need for ramp up of part production before we transfer the process to the customer, we can also offer this service. So now I think, okay, process development, what is that? How long does it take? How many steps is that? I would like to give you a short overview that you can see, and do not need to be afraid of that. Yeah, it's not magic, but it takes time. It takes several levels that you can jump in the gondola from Improve and get step by step from technology readiness level that you might know already from aerospace industry, from TRL1 reach to TRL9. But you do not need to wait until TRL9 until you can do something. No, every step in between gives you the possibility to do already application development. And typically we start first with the requirement specification. We check with you as a customer, your technical and economic requirements, and check which material you should use, which process, which machine we would recommend to you. The second step might be, if the material already has a feasibility study and basic parameter, might be for some materials that Farsoon has already a basic parameter, then you have already a feasibility study, and we could right now, or you could right now also start with that basic parameter application development. But we would offer that for you at Improve already to start that, doing a concept proof. So check with the concept proof how far away we are from your requirement spec, or do we hit already requirement spec? If we're really close to hit the requirement spec, we can jump to the next level, to the development phase, optimize the process parameter. And if it then hits your requirement spec, we verify the process. Then we can start to transfer the process to you as a customer, offer advanced training specific on this material and on the process. And then you are ready to do application development on your own, your place. Optionally, you can validate depending on the demand of you and how good a process needs to be qualified or validated. Can do application validation. Then we can offer process support, because then we know from batch to batch, reproducibility, machine to machine. Yeah, it's some effort. And in the end, you can do the application qualification. So that's it from my side. Thank you very much for your attention. Give me and Bernd the time, and happy for your questions. Happy to address us directly after this webinar, contact data for any questions. And we are also at Fornex, didn't show on the slide. We are Bernard and me are present at the Farsoon booth. So hand over to Alex.
Awesome. Thank you, everyone, for the awesome presentations. That was great. If everyone in the attendee have any questions at this moment, please drop them in the Q&A. We'll be happy to address them. And of course, like the gentleman mentioned, if you are in Formnext later this month, please be sure to stop by our booth and pick their brains. Obviously, their worth of knowledge. All right, give it a few minutes and see if any questions trickling in. And after today's event, like I mentioned in the beginning, this event is being recorded. So we'll be trimming off some of the stuff, just make sure it's more conducive, and we'll be sharing this content on our social media and our YouTube channels in the near future. All right, it doesn't look like we have any questions. It means we did our job. Thank you, gentlemen. Again, thank you for everyone's attention, taking your busy times to come to this event. And thank you, gentlemen, for the awesome presentation. And with that, we'll see you guys next time.
Thank you, Alex. Bye. Cheers to the audience. Bye.
Cheers.
Thank you. Bye.
Bye.